Hi everyone. In this question, we are looking at how we can solve this given equation, this very long equation, using this property that we have. Okay, this property that says that log base am is equals to log base an implies that m is equals to n. Let's pay attention to a few things over here. So in this equation, right, we have log base am, and on the right we have log base a again, but now it's n. So what this property is saying is just if we have the same base for the logarithms on both sides, then we can just say that m is equal to n. We can sort of ignore the log base a already. So now let's look at what we have. So what we have, right, is an equation of two sides, of course. So what we want to get, right, to make use of this property is that we want to make sure that our left is not such a long log. There's no plus over here. We don't want the plus over here. We want it to be just a single log. That means log something equals to log something. I'm just going to put a circle. Because once we have this, right, then we can make use of property that says that our this box is equals to this. And of course, the basis for the logarithms must be the same. So now let's do this together. So our equation is log base 2x minus 3 plus log base 2x minus 4, and this is equals to 1. Okay, because we want to express the left hand side as a single log, so here, right, the choice is very obvious because we have log base 2 something plus log base 2 something. And once we have this, right, we know that we can apply the product law of logarithm. So this will be just log base 2 of x minus 3 times x minus 4. Okay, and to apply this property, right, we want to make sure that on our right is also log base 2 or something, because we realize that we must have the same base on both sides. So here we want to have log base 2 or something. So now I'm going to teach you a trick. So this trick, right, is going to be very natural to you after a while. I'm just going to copy this 1 down, but I'm just going to add something behind. This something behind is log base 2. Now let's just analyze what we did. So log base 2. Why do we add log base 2? I'm going to discuss this. Log base 2 is actually 1 because we know that log base a is 1 for any a that's positive and not 1. So here log base 2 must be 1. So we are not actually disturbing the equilibrium of the equation. So log base 2 is 1, which means that we have our 1 times 1, which is still 1. We are not changing anything to the equation, just adding something. But why do we choose log base 2? We can choose anything. We can choose log base 5, log 1 million, they are all fine. But it doesn't make sense over here. Because on our left, right, we have our log to be of base 2. So on our right, it's natural to choose the same base, log base 2 also. Because what's going to happen next, right, is this. I'm going to rewrite the left hand side because I'm not doing anything to it yet. But on our right, we can actually apply the power law, which says that 1 log base 2 is log base 2 to the power of 1. I just simply move this 1 upwards. Then now you can see it already. We have our log base 2, x minus 3, x minus 1 on the left. On our right, we have log base 2 to the power of 1. So now we are in a position to apply this property. So x minus 3, x minus 4 is equals to 2, because 2 to the power of 1 is 2. And then now we just have to open this up. So opening this up will give x squared minus 7x plus 12. And then we rearrange the equation and then factorize it. So x is equals to 5 or x is equals to 2. So now we have to be careful. because after we have this, right, make sure you must sub in to the original equation to check. So now let's do our checking. So if x is equals to 5, our left hand side would be log base 2 5 minus 3, which is 2, plus log base 2 5 minus 4. Log base 2 5 minus 3 is log base 2 2, which is 1. Log base 2 5 minus 1 is log base 2 1, which is 0. So this is equals to our 1 is equals to our right hand side. So x equals to 5 is okay, it's a solution. If x equals to 2, the next one, then our left hand side would be log base 2 2 minus 3. This is the problem already, because 2 minus 3 is negative 1, it's undefined. So actually I know there's something wrong already. This one also is a problem. So it's undefined. So we will say that since log base 2 negative 1 is undefined, x equals to 2 is not a solution. So our answer would be, therefore x equals to 5, just one solution.